Hello everyone, I'm Paul and today we're solving problem 3341. Find minimum time to reach last room 1. This is a medium problem, but I think it's interesting and it can be useful to practice shortest path. So keep watching for the intuition, approach and solution. We're given a grid of rooms in a dungeon, such as this one, and each value in each room represents the time where you can start moving to that room. And we start here from the upper left corner from the source, and we need to return the minimum time to reach the last room, this room over here in the bottom right. So the first observation we can make is that the first value in the first room is useless. It doesn't matter if this is 99, 7, 8, 18 or whatever, because we start here and initially the time is 0. So as we are already here, we can wait 4 seconds and start moving right or down. Now let's say we're here and the minimum time to reach the first room, as we said, is 0. The minimum time to reach the room in the right is 4 plus 1. The minimum time to reach this room is also 5. And the minimum time to reach the last room would be 5 plus 1, 6. So we return 6. Now, in case you didn't notice yet, this is like finding the minimum path in a weighted graph. And there's a great and popular algorithm to solve this, which is Dijkstra. So now we will go with another example and how to solve this. Let's say this is our dungeon, and in blue we have the minimum distance to reach each room. So as we said before, the minimum distance to reach the initial room is 0 because we are already here. And we will say the distance for every other room is infinity. Okay? Let's say we're here at the source and we are trying to move to adjacent rooms here and here. Now, what will be the minimum time by the time we reach this room? Well, it would be the maximum between the current time and the time we need to start moving to this room plus 1. And this is 7. And if 7 is smaller than the current distance to this room, which is initially infinity, well, in this case we can update the minimum distance in this room to 7. And we can apply the same logic here. The maximum between 0 and 79 is 79. 79 plus 1 is 80. And 80 is smaller than infinity. So here we put an 80. And now each time we want to take first the value with the minimum time. To do this, we'll use a priority queue, and this is key for this algorithm. So now we're here, and the maximum between the current time and the time we need to start moving to this room is 32. And 32 plus 1 is 33. So here the minimum distance to reach to this room is now 33. And remember, we are moving to adjacent rooms, so if we were trying to move to the source room again, for example, well, in this case we will need to find the maximum between 7 and 94, which is 94. 94 plus 1 is 95, but 0 is smaller than 95, so this will stay as it is. And now the next room is this one, because 33 is smaller than 80, so the maximum between this and this is 33. 33 plus 1 is 34, and 34 is smaller than infinity. Next we continue with this one, and we are trying to move here and here. So the maximum between 34 and 62 is 62, and 62 plus 1 is 63. Here the maximum is 82 plus 1, 83. Now we are here, and the maximum between this and this is 63 plus 1 is 64, and that's smaller than infinity. Now we are here, and the maximum between this and this is 69 plus 1 is 70. Now we're here and we are moving here and here. So the maximum between this and this is 70, plus 1 is 71. And the maximum between this and this is 84. 84 plus 1 is 85. Now we're here and the maximum between this and this is 71, plus 1, that's 72. So this is now 72. And now once we have all of this information, we know what's the minimum time to reach the last room. So we return 72. Now I know this can be confusing at first, but I recommend you to learn this algorithm because it can be useful for future problems. Finally, time complexity for this one will be big O of nm log nm, and space complexity will be big O of nm because of the 2D array we are building to store distances. So now let's go with the code and hopefully you will get the idea. First, n equals length of move time, m equals length of move time at 0. Next, we want to create the priority queue, so q equals an empty array, and inside we will store the information for each room in the form of weight or minimum distance to that room, I pointer and j pointer. So for the first room we will use 0, 0, 0. Next we want to create our distances array, and here we will store the minimum distance to each room, so we will call this dist, and this equals an array, and this has another array inside with infinity initially. We want to multiply this by m for every value in the range n. Okay, so this is how we create our nested array for distances. And distance to source, distance is 0, 0 equals 0. This is very important, remember to do this. And next, while we have something in our queue, while queue heap priority queue dot heap pop, we want to pop the first value in our priority queue, and this will give us a weight, an I pointer, and a j pointer. And now we want to fill the distances array for the adjacent rooms, and we can do that like this: for di dj in 1 0 minus 1 0 0 1 and 0 minus 1. Our new I will be the direction I plus our current I, and similarly the new j will be direction j plus j. Okay, so now we are checking if these values are inbounds. So if ni is smaller than 0, or nj is smaller than 0, or ni is greater or equal to n, or nj is greater or equal to m. If this happens, we are out of bounds, so here we need to continue. Now, if we are inbounds, we want to take the maximum value between the current weight or the current minimum distance to the current room and the value in the array move time at new I and new j, and we want to add a +1 because we are moving to that room. So this will be our current value, And next we are checking if this value is smaller than the value at dist and I and j. Remember, this is initially infinity for all the rooms. So if the current value is smaller than that, distance and I and j will equal the current value, and we want to add to our priority queue the new room. So heap priority queue dot heap push queue, and the new room will contain the current minimum distance, new I and new j. And finally, once we have all of this information, we can return the minimum distance to n-1 m-1. So this is the entire code, and now we'll submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.